Welcome to our next homework review video. This is going to focus on the task 4 GL assessment, and we're going to be looking at block 4 week 5's tasks. So having a little look at the homework overview, you can see here that in week 5 we've got angles to be looking at, and that's going to be on pages 111 to 112 in the Collins 11 Plus Maths, Arithmetic and Word Problem book. And we're going to also looking at tasks around shape, same book, and that's going to be on pages 118 to 119. There's also some topics to focus on the CGP online platform. Please do have a go at those. Symmetry, 3D shapes, coordinates, and some mixed practice as well. So let's have a look first of all though at the angles section within the Collins 11 Plus Maths, Arithmetic and Word Problem Support and Practice Workbook. So I'm just going to shrink it down just so we can have a little look at those questions and make some annotations as we go along. So we're going to focus on the timed test 15. This is on page 111, and we're going to go through each question in turn, talk about how we achieve the answer, and hopefully you'll be able to follow this. So in order to go through this video, hopefully you've completed all 15 questions, and now you can mark them if you like with me as I go through them, and hopefully if there's any that you do get wrong, you'll understand why. So let's have a look at question 1. Two angles on a straight line are 130 degrees and 19 degrees. What is the size of the third angle? So the first thing that you need to know here, and certainly with a lot of these questions you do need quite a bit of prior knowledge, that a straight line, let's just draw out a straight line down here, is going to equal to 180 degrees. So if we're given two angles, one's 130, one's 19, if we add those together, we get 149 degrees. Now, in order to work out the third angle, we're going to need to subtract 149 from 180. So 180, take away 149 degrees, gives us our answer, which is 31 degrees. And you can always double check that by saying, well, 149 plus 31 gives us 180 degrees. So the answer to the first question is A. But remembering that a straight line is equivalent to 180. Question 2. A ship was facing southwest and turned the bow 270 degrees anti-clockwise. Which way is the ship facing now? Now I've got over here, as you can probably tell in the corner, I've got my compass points written out already. Now I think for a child in the exam you could quickly jot down your compass points and that will help you with this question. So first of all, the ship is facing southwest. So I'm just going to do a little dot here on the southwest. So imagine that I'm facing southwest. Now the important thing on this question is that we go anti-clockwise, otherwise we're going to get a completely different answer. So as we're turning 270 degrees, I like to think of that as 3 90-degree turns. So let's work it out. One 90-degree turn will take me to southeast. A second 90-degree turn will take me to northeast. I've gone through 180 degrees there, and then one more 90-degree turn will have me facing northwest. So the answer is E. Having a look at question number 3. A regular shape has 8 sides. How many degrees is each individual interior angle? Now I've got a very useful little equation here that I'm going to give you. I'm just going to rub out these jottings from the previous question and just talk to you about how to work out the interior angles of any shape. So the first part of the equation is n take away 2, that's the first bit, and then we're going to multiply by 180 degrees. Now in this formula we've got the n is equivalent to the number of sides. So depending on the shape that we're working out, we can just slot that in And in this particular question, it's actually asking us to work out 8. So what we're going to do is we're going to put 8 in here. And we're going to say 8 take away 2. We're going to obviously do the brackets first. Gives us 6. And then we're going to times that by 180. So 180 multiplied by 6 will give us our answer. So let's just quickly do that now. 6 times 0 is 0. 6 8s are 48. 6 times 100, 600. Don't forget about the 4 down here. And that will give us 1080 degrees. But because there are 8 angles, then we're going to need to divide that by 8. And that will then give us 135. I'm just going to show you how that looks over here in terms of division. So that's the total amount of degrees. And then if we divide that by 8, because remember we're trying to work out one individual, so we're going to do 8 into 1 doesn't go, 8 into 10 goes once, remainder 2, 8 into 28 goes 3, remainder 4, 8 into 40 goes 5. So one interior angle is 135 degrees. So that's a really, really useful formula, and I'm sure as we go through the questions, we will also come back to that as well. Let's move on to number 4. If Zach faces northwest and turns 135 degrees clockwise, which way will he be facing? Now, what I'm going to do is just bring back I'm going to copy this over to the next side so you can see the compass points again. Okay, but again, there's no harm in the child just quickly sketching that out to help them. So if Zach is facing northwest, him facing northwest here, and he turns clockwise, maybe just putting a little arrow there, 135 degrees, which way will he be facing? Well, we can break down that 135, if you like, into 90 and 45. So a 90-degree turn, we'll have him facing northeast, and then we're going to add another 45 degrees, and then that will mean that he's facing east. So Zach will be facing east, which means the answer is D. Moving on now to question 5. Inside a scalene triangle, 2 of the angles are 21 degrees and 67 degrees. What is the size of the third angle? So it's really important here to understand that within a triangle, and it doesn't matter whether it was a scalene, whether it's an equilateral, an isosceles, a right angle triangle, the angles will always add up to 180. So a bit like a straight line. So in order to work out the answer here, we're going to need to do 21 degrees added to 67 degrees. Hopefully you can all probably do that in your head. So that gives you 88 degrees. And with that then, we're going to need to take that or subtract that away from 180, and that will give us our third angle. So 180 minus 88 gives us 92 degrees. So what's the third angle? It's 92 degrees, which is E. Moving on then to question 6. How many sides does a shape with interior angles totaling 1,440 degrees have? Now if we think back to the previous question where we were thinking about that formula, we can use that to help us a little bit here. So remember, it's n take away 2 times 180. Now, if you remember back to when we had the octagon, the 8-sided shape, and we did 8 take away 2 times 180, we got 1080 degrees. Well, that isn't quite enough. So looking at your answer options, you can rule out, for example, 6. We'll rule out the 8, which we've just discussed, and that just limits your choices. So why don't we just try another number and see what happens. So we're going to try 10 and see if we get that as our total. So 10 take away 2 is 8. we're now going to need to do 8 multiplied by 180 degrees and see if that gives us our answer. 8 times 0 is 0. 8 8s are 64. 8 times 100 is 800, plus the 6 that we've carried down here, and that will get us 1,440 degrees. So the answer is E. Moving on now to question 7. Often within the 11 plus, you will link degrees to other areas of mathematics. And in question 7, you can see there's a link between the degrees and time. So the question says, how many degrees are between the hour hands at 10 o'clock and 2 o'clock on a clock face? Now, we've tried to illustrate that here. So we've got the line pointing towards the 10, and we've got the line pointing towards the 2, or the hands pointing towards the 10 and the 2. One of the things to know here is that a full rotation all the way around the clock is 360 degrees. Now, what would be quite useful here is to know how many degrees there are between the different numbers on the analog clock. So if we do 360 divided by 12, that will give us 30 degrees. And that means that between each of the numbers, it's 30 degrees. So to help me get the answer here, I can say that there are 4 equal spaces between 10 o'clock and 2 o'clock moving clockwise. Therefore, to get the answer, we're going to do 30 multiplied by 4, which gives us 120 degrees. So the answer is C. Question 8. The top angle of an isosceles triangle is 40. What is the size of one of the base angles? Now I'm just going to get an isosceles triangle here and just draw one out for you so you can understand how this question is worked out. So it describes the top angle of an isosceles triangle as 40 degrees. So this angle up here is 40. And our job is to work out one of the base angles. Now the key bit of information here is the fact that the 2 base angles are actually the same. So how are we going to work it out? Well, we know that the total is 180 degrees. So we're going to do 180 subtract 40. That was the angle they gave us already. And that gives us 140 degrees. Now remember, we've said that to find the base angles, because they're both the same, we can divide that by 2. So 140 divided by 2 gives me 70 degrees. So what is the value of each angle? It's 70 degrees. So one of the base angles is 70. Moving on now to question 9. And again, I think we can probably just make this a little bit bigger so you can see it clearly. So in the pentagon below, what is the value of m? Now, you can use any letters here, and if you remember back to our algebra video, we said that you can use any letters that you like in algebra. It just happens they've used M here. So we've got a pentagon. Now what would be quite useful here is if we know the total that we would need inside. So the sum is actually 540 degrees. So altogether, if we were to add up all those angles, that should be the total. But because we've only been given 4, we're going to need to add those up, and then we're going to subtract it from 540. So let's do that now. So we've got 115, 110. That's probably an easy one to start with. That gives us 225 degrees. And then we've got 2 90s, which we know makes 180. So I'm just going to add those numbers up together. Again, just keeping it nice and neat so it's easy to add up. And that, of course, gives us 405. So what we're going to do now with 405 is we're then going to subtract that from 540. And that will then hopefully give us our missing angle, or if you like, angle M here. So we can't do that, so we're going to need to go and borrow. and we have 135 degrees. So the missing angle is 135 degrees. Not all of these things are always drawn to scale, but certainly that will show you how to work it out. Moving on now to question 10. We've got, what is the value of x? So this diagram here quite clearly shows you've got a straight line, so that's 180 degrees. And then when we have a box like that, that indicates to us that that is a 90-degree angle. So 21 and 90 is going to give us 111 degrees. And then with 111 degrees, we're then going to need to subtract that from 180. So 180 minus 111 is going to give us 69. So let's just double check that's one of the answers, and it is, it's B, 69 degrees. So as you can see, as we go through all these questions, there are some really useful facts to know. Things like 180 degrees on a straight line. Also knowing, for example, how many degrees inside a triangle or a quadrilateral or even a pentagon. Using that formula maybe to work out some shapes that have more sides. Maybe making yourself maybe a little booklet with all these key facts will really help you. Let's move on now to the last 5 questions. We're going to have a look now at number 11. Which of the following is a reflex angle? So a reflex angle, and you might have learnt this within the learn section, is an angle that is greater than 180 degrees. So we need to have a little look and see. So we can see here it's not going to be 79, that would be what we'd call an acute angle. It's not 37 degrees. It's not going to be 150 or 179 because they're both less than 180 degrees. So the answer is 202. If you do want to know a little bit more about acute, obtuse, reflex angles, then obviously read the learn section and make sure you know the answers. Question 12. One angle measures 35 degrees. What is its supplementary angle? Now with a supplementary angle, they always total 180. So if we subtract 35 from 180, we get 145 degrees. Question 13. A boat turns its rudder 55 degrees. What would its complementary angle be? Now, a complementary angle always totals 90 degrees. So again, to work this one out, you're going to need to do 90 subtract 55, which of course gives us 35 degrees. Now, both the supplementary and the complementary angles, again, it's worth knowing those key facts. Question 14. Inside a kite, there are 3 angles measuring 95, 95 and 58. What is the 4th angle? Now, in this particular question, it's important to realise that a kite is a 4-sided shape. So we're going to need to think, well, what would the total of a quadrilateral be? Well, it will be 360 degrees. And that doesn't matter whether it's a rhombus, parallelogram, any 4-sided shape will give you that as your total. Now, we've been given 3 angles already. So if we add those all up, then we can take that away from 360. Now, what happens if you add them up, you get 248 degrees. I'm sure you could quickly add those up. I actually thought about doing it as 100 and 100 and then subtract the 10 from 58 to give me 48, which again just makes it easier to work out. And then we can do our subtraction and we'll hopefully then get our missing 4th angle. And that gives us 112 degrees. So well done if you got that correct. And the last final question in this section is, a car windscreen is the shape of a trapezium. So again, a 4-sided shape. It has 2 angles of 72 degrees. What are the other 2 angles combined? So the 2 angles of 72, if we do 72 plus 72, that's going to give us 144 degrees. And then we need to take that away from 360. Remember, it's a trapezium, so it's a four-sided shape. And then that will give us 216. Now, it was asking us for that combined. So 216 degrees is going to give me the answer B. Right, well done. Let's move on to the next section. We're now going to focus our attentions on the shape section, and that will be in the Collins 11 Plus Maths, Arithmetic and Word Problem Book again. And we're looking at pages 118 to 119. So let's go and have a little look. First of all, just a reminder, this is the book that we're focusing on. And we're going to be doing the timed test 16 on page 118 first. So we're going to go down through. Do find with a lot of these questions, certainly within the succeed section, they are very much sort of general knowledge. So hope you've enjoyed working through these questions, you've completed them, and you're ready now to go through and mark them. So let's have a little look at the first question. Which of the following pairs of lines are parallel? So parallel lines should never meet. And if we have a little look at A, they look a little bit like train tracks, don't they, those? And if I just run maybe some slightly clearer lines over them, there we go. Those lines are parallel. They'll never actually touch. So that is the answer, is A. Just double check with the other ones. If you look at D, that's sort of perpendicular. Then C, a crossing over, and B actually go to a vertex or a corner. So it's none of those. Having a look now at question 2. What is the sum of the sides of a nonagon and a decagon? Now, important to realise the word sum means the total. So we are going to need to add those up. So a nonagon has 9. Dec, if you think of decade, so decagon has 10. And if we add them up together, we of course get 19. So it's certainly worth learning, of course, all of your shapes, making sure you know how many sides, what the properties of those shapes are. You'll probably do shape a little bit at school, but maybe slightly more advanced for the 11 plus. Question 3. A triangle has angles 95, 11 and 74. What is the name of this type of triangle? Now, we've just been doing angles. I know we've talked a lot about interior angles, but to recognise the name of this triangle, we need to realise that, of course, all the angles are different. 95, 11 and 74. Therefore, it will be what we call a scalene triangle. So if the angles are all different, the triangle is referred to as a scalene. Moving on to question 4. What is the order of rotational symmetry of a square? Well, the order of rotation is the number of times that a shape can rotate exactly and still be the same shape in terms of the way that it looks. And because this contains 4 sides, this has an order of rotation of 4, because we can rotate the shape. And if we have a little look at an example here, so if I was to draw out my square here, you can see that it won't matter if I rotate it. There we go, once, twice, 3 times, 4 times. And actually, to make that process even easier for you to understand, if I put a little dot here, as we rotate it, you'll see how the dot moves around, but I've got the same shape. Or sorry, the shape's moving, the dot remains still. So 1, 2, 3 and 4. If you don't understand rotational symmetry, please do have a little look also on the BBC Bitesize website. There's some really good videos on there which also explore other shapes or other 2D shapes as well. Now, on question 5, you had to use this word bank at the top and slot it into the different spaces. So we're going to start with a rectangle has 2 pairs of equal sides. The angles are all equal and the diagonals are equal. Each angle is 90 degrees. This shape is sometimes called an oblong. It has 2 pairs of parallel sides. So hopefully that helps you work out which of those words go in. There's no words left over. They've all got a space, and you can add those in so that paragraph makes sense. A bit like a closed test, which I know a lot of you are familiar with. Question 6. Multiply the number of vertices to a heptagon has by the number of edges an octagon has. So vertices on a heptagon, there would be 7. So I'll just show you a 7-sided shape here, just so you can see. So when it's talking about vertices, of course, it's talking about the corners. We've got 1, 2, 3, 4, 5, 6, and 7. And the number of edges on an octagon. So if we draw out an octagon, the number of edges that it has, 1, 2, 3, 4, 5, 6, 7, 8. And of course, oct gives you a bit of a clue if you think of an octopus for how many legs it has or tentacles it has. So multiply the number of vertices a heptagon has by the number of edges an octagon has. So therefore, we're going to do 7 times 8, which is 56. Question 7. All quadrilaterals have 4 sides. A trapezium is a 4-sided shape. So this is what we call a quadrilateral. 1, 2, 3, 4. It's a bit like a car windscreen when you look out of it. And it has 1 set of parallel sides. Question 8. To divide the number of sides a nonagon has by the number of sides a scalene triangle has. So we were talking about scalene triangles earlier, so of course it has 3 sides, and a nonagon has 9. So it'll be 9 divided by 3 to give me 3. So these little facts, these again, a bit like when we talked about angles, it might be worth making a little booklet or writing down these key facts that you need to remember, and hopefully in the exam then it will become really easy and you'll know all those key elements around not only angles but shape and space. Number 9, which of the following shapes has 8 sides? I've actually just shown you one, and if you have a look at D here, 1, 2, 3, 4, 5, 6, 7 and 8. Number 10, which of the following pairs of lines are perpendicular? So perpendicular lines create a right angle. So the answer to that one is B. Question 11. A cuboid has 6 faces and 8 vertices. So Zoe has a cuboid shaped box of chocolates. What is the total of its faces and vertices? So one of the easiest ways actually to draw a cuboid, I'm just going to sketch one for you now, is to do it like this. Join up the corners. And then we've got our cuboid shape. So the total number of faces, if you think about, there's 4 going around the middle, one either one either end, so that makes 6. And the vertices are the corners. So we've got 4 on either end. So there's 4 there, another 4 that end, so that makes 8. And we need to find the total. So it's going to be 6 plus 8, which is going to give us 14. So question 11 should be A. Question 12. John's pencil holder on his desk is a hexagonal prism. How many vertices does it have? Now again, a prism, a bit like we did the cuboid, we can do that in a similar kind of way. So if we grab ourselves a hexagon, just going to do one over here in the corner and draw another hexagon there. One's a little bit more complicated to draw, but if we again line up all of those different edges, make sure we're joining it up with the right ones here, then we are going to make a hexagonal prism. There's one there that's just about C. So there we go, there's our hexagonal prism, and we've got to then decide how many vertices does it have. So the vertices are the corners, so there are 6 at this end. Okay, if I went round, did a little dot on each of them, and then of course we've got another 6 at the other end. So if we add them up together, of course we're going to get 12. So how many vertices does it have? It has 12. Moving on now to question 13. Multiply the number of faces a cone has by the number of faces a triangular prism has. Well, with a cone, you can work out that the cone has 2 faces. I'm just going to write that up there. We'll do it next to the cone. And then we've got how many faces of a triangular prism. I think it might be worth drawing a triangular prism for you again. We'll just do it here. Ask us how many faces is it got, so we'll see once we've just drawn it. We've got the triangular prism drawn out. So the faces is 5 because we've got, let me just show you, we've got 1 here, 1 here, and then 3 going around the middle if you like. So 5 in total. So we're going to do 2 times 5 to get our answer, and of course that is 10. Important we are multiplying and of course not adding. What is the name of the shape when this is folded? Well, the key part here is to look at the square here, and that's actually the base. And then we've got all these other triangles that when we pull them up together, we're going to create what's called a square base pyramid. So if we have a look at the other options, we've got a hemisphere. No, that's sort of half a sphere. We know that's not right. Sphere, it's a bit like the shape of the earth. That's not right. We obviously know what a cube is, like a dice, but the square base pyramid is the net that we've got here. So I would just think of that square there as the base. That's the best way of thinking about it. And then to pull all those triangles in and around to make a point at the top of the pyramid. And that is called a square base pyramid. Question 15. We've got how many hemispheres are required to make 6 spheres. So a sphere is like the shape of the earth, and we require 2 hemispheres to make 1 sphere. So if we've got 6 spheres, we need to do 6 times 2 to give us 12. So the answer is C. Thank you very much for watching this video. Hope you found it useful, and I look forward to seeing you next time. Bye bye.